Hello and welcome. Today we're going to be talking about the USACO training problem. This is on the USACO training website, which is train.usaco.org. It's problem number 1 called Your Ride is Here. The basic synopsis of the problem is to output either the word go or stay based on two strings that we're given here. String 1 and string 2 are shown, and each are separated by a new line. And basically, we have to take the product of the alphabetical positions of each character and take the modulus of that product in 47, and we compare the two modulus to see if they're equal. If they are, we print out the word go, otherwise we print out the word stay. Let's take a closer look at this problem through pseudocode. And remember that pseudocode is a very important habit to have when you do these kinds of problems, as pseudocode helps you plan and step out your code before you actually write the nitty-gritty little details of it. Let's start by analyzing the inputs. My bad, I'm just going to change the font real quick to something. So we have the first input, which is going to be comment. I'm just going to space it out a little bit to make it easier to understand. And oops, I forgot the Q. So what the output says here is that comment is the third letter of the alphabet, so we multiply by 3. Next we move on to the O. O is the 15th letter, so we multiply by 15. Next is M. M is the 13th letter in the alphabet, so we multiply by 13. And E is 5. T is 20. And Q is 17. This gives us a final product of 994,500. But remember, we have to take the modulus of this in 47, so we denote this using a mod, or this is also the percentage character in code. And this is 27 in mod 47, meaning that the remainder is 27. Let's go ahead and take a look at the next string. I'm just going to copy paste this over. Next string is H, V, N, G, A, and T. H is the 8th letter, so let's go ahead and multiply by 8. V is the 22nd. N is the 14th. G is the 7th. A is the 1st. And finally, T is the 20th. I'm so sorry, this is a little bit unformatted. And then finally, we have to find the product, which is 344,960. Take the modulus of that in 47 in order to get 27. So notice the fact that both of the answers in mod 47 are 27. So therefore, the output is go. If the value was 29 rather than 27 for the second one, then 29 does not equal to 27. This is not true. Since this is not true, we would have to output stay. Okay, the next challenge that we have is how do we figure out how to find each alphabetical position to multiply by? Like, how do we figure out that C is the third letter of the alphabet? In order to understand this, let's take a look at the ASCII chart, which is a table which shows the integer values which the computer represents these characters with. I'm going to zoom in right here. So as you can see, ASCII chart starts at the letter A and ends at letter Z. Note that this problem only requires uppercase letters, but lowercase letters start at 97 and end at 122, but that's a side note. The main important thing is that we want the A to start with 1 rather than 65. How can we do that? We can subtract by 64. And since 65 minus 64 is 1, now all the letters minus 64 will result in their alphabetical position. In other words, we just subtract by 64, but if we want to think of it in a more intuitive way, we can use character subtraction, which is just subtracting the integer value of the character and just subtract by the @ symbol right there. So I will say subtract by the at to get alphabetical position. Okay, next is let's take a look at the actual algorithm on how we can solve the problem. First things first, we have to obviously read in the input. That is a must, otherwise we cannot even analyze anything. We'll just be filtering nothing. Let's read in the input. Next problem is to take the input and get their modulus value. In order to do this efficiently and to reduce redundancies such as repetitive code, I'm going to use a method. A method makes it easier as you can just call the method repeatedly. Let's just define this method as mod product and takes in the string. And take the mod product of each string, each input, in other words. Finally, we have to make the decision whether the mod products are equal. And based on this, we either output go or stay. This is a basic algorithm, and as you can see, it's pretty simple. But let's go ahead and flesh out some more details of mod products specifically. Let's define function mod product. Here we're gonna need to define a running counter variable to represent the product, and also on top of this we're going to use the most efficient type, as it's not good practice to use bad types, but in competitive programming we generally use integers. That's why I just typed out int. But let's reason it out. Now the largest string will be z as said in the input. It'll be six letters long, and the largest character value is 26, as 26 is the last letter, z. So the greatest number that we can produce is 26 to the 6th. 26 to the 6th, to give you an idea, is around 300 million. I'll zoom in. Okay, it's 308,915,776. That's the exact value. I'll just say it's around 308 million. 308 million is very small operations in a computer, and it can be stored in an integer which holds around 2 billion. It can hold a number as big as 2 billion. So we're going to use a running counter, this integer, more like actually, I should call this a running product sum. Next, after we define this, whoops, I forgot to write define. And once we define this, we have to go through each character. And for each character, we have to multiply the product sum by the ASCII value. The ASCII value is referring to this here. This decimal here, that's the ASCII value. And as we talked about before, we have to subtract 64 from it, which is also the character. This also works in general programming languages. Finally, we have to return the value. Return product sum. But here's the caveat. We have to take the mod of 47, so we have to use do product sum mod 47. I'll just denote it using the words here. So this is the basic pseudocode of how to solve this problem. It may look complicated at first, but I suggest to always do pseudocode, as once you do the pseudocode and do the actual calculations, the problem turns into a really simplified version which you can quickly code. So make sure to do pseudocode, as it makes problems really simple, and it turns these USACO challenging problems, such as this may be challenging to people on their first try, but it becomes easier through the use of pseudocode. I hope this video helps, and if it did, please like, share, and subscribe, and make sure to hit the notification bell. But more importantly, once you learn and understand the pseudocode that I've provided for you, I will attach the code for you if you cannot solve the problem. I'll attach the code in the description. And thank you very much for watching.